nutrient, other chemicals. The most important adsorbers are clay and organic matter. And therefore, when your soil is rich in clay and organic matter, then your soil is fertile and you are getting maximum crop production as compared to your soil having a sand particle and your soil having no organic matter. Then adsorbed nutrients are available to plant. Whatever nutrient adsorbed by the plant, that nutrient has been taken by the plant. Then adsorbed nutrients are not prone to loss in drainage water. So whatever nutrient adsorbed by the plant, that has been not lost in drainage water because it is adsorbed on the soil surface. Soil absorption capacity can be accelerated, leading to greater nutrient loss. When the absorption power is increasing, then there will be loss of nutrient in a soil. Then physical properties of soil. So here it is a soil fraction or soil separate, correct? Or soil particles. So gravel, sand, silt and clay. The size of the each separate larger than 2 mm gravel, sand 0.05 to 2, silt 0.002, 0.05, then smaller than 0.002 mm. So all the soil separate we are seeing with our naked eyes, but clay cannot be seen, and for that electron microscope are required. Then gravels are coarse, sand gritty, silt floury, just like flour, wheat flour, and so on. Then clay sticky when wet. So suppose you take the clay particle, then you wet it, you add the water, then there is a sticky in nature. So clay is sticky in nature. Then soil consists of solid, liquid, gases, and biotic compounds. Sand and silts are merely broken down rocks. Cracks consist of quartz, feldspar, mica, or other minerals. So sand and silt are broken down and having the quartz, feldspar, mica, or other mineral. Chemically, they are essentially inert compared with clay and organic matter. So I many times told that sand is a inert matter as compared to clay and organic matter, which are responsible for most of the chemical reaction in the soil. So in your soil, clay and organic matter is absent, then your soil is poor in fertility and you are getting less crop production. Then here it is a silt particle and here a clay particle and here a sand particle. So clay particles are plastic and sticky when wet. We have seen clay particles are plastic when we are moist it or when we wet. They are highly absorbing of water, gas and dissolved substances. Clays are minute plate-shaped aluminosilicate crystal consist of silicon, aluminum, iron, magnesium, oxygen, hydrogen. There are several types of clay. I told that two of the most important ones are kaolinite and smectite. Smectite clay have the ability to swell. You know that when there is a smectite clay or Montmorillonite clay in black soil or clay soil, and when you are apply the water, then the clay particle has been swelled on wetting and screen on or when dry. So clay particle or black soil, when you are apply the water, then it will swell. And when it is dry, then there is a shrinkage. You will find the cracks when these black soil are dry. So you know that when there is a crack You grow the seed. Suppose you are sowing the seeds of the maize or other crops. Then you are irrigate the crop. Then the soil is well and germination has been started. But your soil has dry, then there will be crack formation. So when there is a crack formation, then the plant has been germinated, so there will be less contact with the soil, and the plant will not get the sufficient nutrient, and the plant has become weak. So we have to manage black soil properly. Smectite enter chemicals more than kaolinite clays. Then clay is negatively charged colloids. So clay has always negative charge and it is a colloidal like clouds. This negative charge is the region that positively charged cations surround each clay particle. So you know that there is a negative charge on the clay particle, then around you will find the positive charge cation of each particle or of each clay particle. The individual cation can be exchanged for each other. So individual cation can be exchanged. I told that calcium, magnesium, sodium, potassium has been exchanged for each other. So suppose I will give example that your soil is a alkali soil or sodic soil, then it is dominant in sodium clay. So for improvement of that soil, we are adding the gypsum, means calcium sulfate to H2O. So the reaction has been taken place and sodium clay come into the soil solution and converted into calcium clay and sodium react with the sulfate, so sodium sulfate. And sodium sulfate is a water soluble, so we have to let down below the root zone. So the sodium percentage or exchangeable sodium percentage is decreasing and slowly your soil may be improving. In previous lecture, I told that when we are eating the more sodium chloride, then we have the problem of the BP and there will be possibility of the heart attack. Similarly, in soil, also when the proportion of the sodium is increasing, then it is harmful for the soil structures and you are not getting the higher crop production. If the cation can get close to the surface of the clay, the negative charge on the clay is largely neutralized and the clay particle will cling together or flocculated. So normal soil are flock, unite together, that is flocculated. Calcium and magnesium are dominant in this area. So when your soil is flocculated, then there will be dominant of the calcium and magnesium. When there is a dominance of the sodium, then there will be deflocculation. Means your soil particles separated, or it is called a dispersion. So your physical property has been changed, destroyed, and there will be hard pan on soil surface. And when you are apply the irrigation water or there is rainfall, then you will observe the waterlogged condition on the soil surface. It is only due to sodium clay particle. And that is why the productivity of the alkali soil or saline soil is low as compared to normal soil because it is deflocculated or dispersion. And when your soil is dispersion, deflocculated, then the aeration is poor. So the poor aeration, then microorganism growth is poor. Plant root not getting the sufficient air. So we are getting very, very low crop production. They are small and effective in holding clay particle together. Then soil texture. So we have seen that soil texture relative proportion of the various grain size in the soil. So sand clays and clay particle, sand silt and clay particle. So it is a proportion how much proportion of sand, silt, and clay in the soil. So on the basis of this, we can find out the type of the soil. So this, to describe soil texture, names such as loamy sand, silt loam, clay loam, sticky clay, sandy loam, and so on. The best soil are generally those which contain 10 to 20% clay with silt and sand in approximately equal amount and fair amount of organic matter. So in Anand and Punjab, Haryana, you will find such type of soil, and it is known as alluvial type of soil. It is very, very rich soil. And you know that Punjab and Haryana is the bowl of rice and wheat, bumper crop production of the rice and wheat, because they have the alluvial type soil and that soil is very fertile one. And soil texture, it is similar. Hmm. In clay, we have seen that it is triangle method. We can see the different soil classification. So it is a percent clay here, percent silt, percent sand. So on the basis of the proportion of the particles, sand, silt or clay, the soil has been classified. Suppose 90% sand and 10% clay, then it is a sandy soil. When there is a 90 to 70% sand and 10 to 15% clay, then it is a loamy sand, and so on. When there is a clay content is more, then it is a clay soil or black soil. It is a very, very fertile soil. And I also told that sandy soil are we can do the easily cultivation operation because there is no friction because sand particle has a larger size. Whereas here the difficult field operation because clay particle is sticky one and more friction is required and more horsepower tractor is required. So 45, 55 horsepower tractor is required, where in sandy soil only 25, 35 horsepower tractor is sufficient. So it is a soil texture triangle. You have to remember this thing. So it is given. So surface area, I told that clay particle has a larger surface area as compared to this sandy soil. So you have written that in comparing clay with sand and silt, it is important to be aware of the relative amount of surface area of this particle size group on the surface that many chemical and physical properties take place. Smaller, more surface area. So you remember that when your soil particle is small, then there will be more surface area. When your particles, soil particle is larger, then you have less surface area. So here it is a clay, here it is sand. So sand has larger in size and less surface area. So again here given the kind of particles, diameter of particle, then percent of particle in grams and surface area. So here you see that here the surface area is 1,13,000 square centimeter. Here only 11 centimeters square, 11 square centimeter. Here 1130. So here you can see that here 1,13,000 surface area. So how much water has been taken by the clay particle or nutrient taken by the particle, clay particle as compared to sand and silt. And that is why clay soil are more fertile. So you remember this thing. Because you know that when there is more surface area, then there will be more absorption of the nutrient and water. When there is suppose in sandy soil only 11 square centimeter surface area, then less absorption of water and nutrient. And for plant, nutrient and water is required. Similarly, human beings also require water and nutrient. Then soil structure. So I told that it is arrangement of individual particles in relation to each other. So structure, you have to see the size, whereas structure, arrangement of individual particles in relation to each other. Hello,
Yes, sir.
सुनाई देता ना? Okay, good, good.
Yes, sir.
Then soil structure is the arrangement of particle into small groups or aggregate. So how do you remember? Soil structure is the arrangement of particles, sand, silt, or clay. How they arrange the particle into small group or aggregate. Aggregate means combination. Sand, silt, and clay may combine together and form aggregate or small groups. Aggregate may be bound together with other aggregate in large masses called pads. So I see we have seen that it is pads. Then pads come in different shapes that roughly resemble sphere, block, column, and plate. We have seen this. Then if the individual particles are arranged in a small aggregate with rounded edge, we speak granular structure. So it is best structure. This is very desirable for plant growth. It provides both large and small pores. So granular structure is very best for the plant growth, and it has both the type of the pore space, large and small pores. Some soil lack structure, as for example sandy soil. The individual grains are independently of each other. So we will not find a structure in sandy soil. So no binding substance hold the particle together, so the soil has no pairs. So for that, improving the sandy soil, we have to add organic matter. 10 ton, 20 ton, farmyard manure, compost, then vermicompost, then green manuring, then cakes we have to add, castor cake, neem cake, and so on. Then pore space. Pore space, I told that when there is a large pore, then it is called macropore. So large pores are readily drained of water and filled by air after a heavy rainfall. They are valuable as an aeration system. So when there is a large pore, then there is a better aeration. And when there is a rainfall or we apply the irrigation, then first they are filled up. Then small pores hold water against gravity and pull water up from the water table by capillary action. So it is also known as micropore. So that water has been filled up and it is also known as capillary action, and that water has been utilized by the plant. So it is a available water you will find in a small pores. They are necessary for the water supply to plant. Ideal structure include large and small pores in proportion that correspondent to the water and needs of the crop plant given for that culture of climate. So when there is a large pores is present in sandy soil, then there is no advantage. When there is a clay soil which contains small pore, then there is a disadvantage. But ideal structure is that there will be equal proportion of large and small pores that correspond to the water. So here you can get the water and air need of the crop plant. So as and when the plant require, we will supply the water and air, and we are getting the higher crop production. And soil temperature. So soil temperature is also important. So just as important for plant growth as air temperature, the temperature of the surface soil fluctuates greatly both during 24-hour period and within the season. So you know that in summer season temperature is greater, and within the season also they change. Suppose you take the winter season, Where the soil is covered by dense growth, કેટલા વાગે છે પૂરું? Where the soil is covered by dense growth of plant or thick layer of mulch, temperature variation are much less severe and do not penetrate deeply. Soil temperature has a direct effect on plant growth and also influence microbial activity. So when the temperature is high, then the microbial activity will be reduced. And you know that when the microbial activity is reduced, then there will be less available nutrient to the plant. So it influences on the plant growth. Then freezing and thawing of the soil water also affects soil structure. Slow and occasional freezing and thawing like under mulch is beneficial for soil structure. So you know that at present the farmers are using the mulch, particularly in watermelon and other crops. And I think it is last one, soil color. So you know that when we will find the black color or brown color of the soil, then that soil is more fertile. So clay soil, also known as black soil, because it contains more particles of the clay and it is a fertile soil. So color of the soil tells us much about some of its other properties. The color of the surface soil origin depends mainly on its organic matter. So why you will find the black color of the soil? Because it contains more organic matter. The darker the soil, the more organic it contains. So when you will find the darker color of the soil, then you assume that it contains more organic matter. This organic matter imparts favorable property to the soil, such as better aggregation and high water holding capacity. So when you are adding the organic matter, then there will be better aggregation and it is a particle just like clay, so it has a higher water holding capacity. It absorbs more nutrient and your soil will be fertile. And that is why the farmers are applying 10 to 20 ton farmyard manure every year or every alternate year. They are knowing, although they are not learn agriculture, but by experience they are knowing that by adding the farmyard manure, our soil can be improved. Also, the dark soil absorbs more radiation during the day and radiate more heat during the night. In subsoil origin, soil color indicates the wetness and aeration condition of the soil. In general, reddish and brownish subsoil indicate good aeration and little waterlogging. Here, grayish and olive color indicate much waterlogged and a chemical reduction of iron. So, waterlogging condition is not desirable for the better growth of the plant. And in saline soil or alkaline soil or sodic soil, you will find the waterlogged condition and it is not desirable. Soil structure has been deteriorated and there will be poor aeration and the plant will take not sufficient nutrient and water. A mottled subsoil, one with a spotty pattern of brownish and grayish color, is indicate of a fluctuating groundwater table. So I think it is the last one, only two. So Munson color system. Define color in terms of hue, value, and chroma. You have to remember, it will be asked in MCQ. So hue was defined as the actual color, red, blue, or green. Then value was defined as how light or dark a color is. Then chroma was defined as a how strong or weak color is. So soil scientists use the Munson color book to determine the color of the soil, to help determine what type of soil it is along with using the texture. So you have to remember the Munson color system, hue, value and chroma. All soil is brown, right? Wrong. Ask the question. So soil vary in color depending on the material makeup and location. So the color of the soil is variation. The Munson system of color notation is a color catalog. So soil scientists compare the soil next to the color chips to find a visual match and assign the corresponding Munson notation with the soil. So what they are doing, they are taking the color strip, color chips, and compare with the soil, and they are looking, visualize, and accordingly they are classify the color of the soil. The wide use and acceptable of the Munson system allow us for direct comparison of soil anywhere in the world. So you can use the Munson color throughout the world, and you can find that in a particular area, such type of soil have color, and you will find the characteristics. So here it is rainbow use spectrum, then value spectrum, then chroma spectrum intensity, here 0 to 10. Suppose you will find color here, then it is 8. Suppose you find color, then it is 2. So color chip comparison. So I told that you have to prepare the color chip, then compare with the soil. Then you can grade it that type of soil is color, soil color factor. So it is a red soil in southern United States. So you can see that it is a red soil. In our India is also some type of soil is present in South India, red soil or laterite soil. So red soil sand in Arizona, in USA, you see. Then red